So let me just, while Simon's getting this ready, happy to talk about homework questions at the start of class. I know we got started a little late, partially because of my fault of switching to Zoom and all that. I would just ask in general that if you wanted to ask a homework question that you had it ready. And I know I just sprung it on you, so I'm not saying Simon should, but in the future, just moving forward, just know that I like to start with homework questions, but I like to make the most use of class time. And so usually like the first 10 minutes of class, I'll do that, which we're already kind of past. So anyway, I just want to mention that in the future, when you start looking at this for Wednesday, let me know. Even ahead of time would even be even better, but certainly having it ready at the start of class would be good. All right, back to Simon. Find that?
So I'm having trouble with problem 17.
Let's take a quick look at 17. This one?
Yep.
So what did you try so far?
So try the value for, or what's it called? Substitution. I tried to use substitution.
Yep.
And it just came out as 0.
Did you get 0 over 0 when you plugged in -9? You're kind of breaking up a little bit. I don't know if it's my internet or not, but I believe that you would get -9 on this one, or I mean 0 over 0. And so to me, I think the options of this one are probably going to be to factor and cancel. That's just what it looks like to me, because I see that the top can be this. And my guess is the bottom factors into one of those things. So and then so do you get 0 on the bottom when you plug in a -9? Did you try that? I haven't tried this one yet. Let's see if I can plug 0 in real quick. Is that what you said, Simon?
Yeah.
I think you can plug in -9. I think this one works, actually. I think just now that I looked at my calculator for a second, I don't think you actually get 0 over 0 when you plug -9 in. I think if you plug in -9, you get 0 over not 0, which is 0.
How come your problem looks different from?
Because everyone gets a different problem. Yeah, sorry, I should have mentioned that too. But so I'm asking you a direct question. When you plug the number in, what did you get? Because that's always the first thing we should try, is just to plug the number in. What did you get in that situation?
I got 0 over 0, I believe.
Yeah, I would double check that. I think the answer to this one's 0. Let's double check. Let me try entering that. It's not right. I wish I saved what I just wrote down. So I do think you should try factoring this one. I don't want to spend too much time on it. I'm not sure we're both on the same page here anyway. Did you try factoring it?
Yeah. I factored them and then I inputted the number, and I still got 0. I don't.
Okay.
I don't know. Maybe I do it wrong.
So it's possible that it does not exist too. It's hard to know. You're breaking up a lot, and maybe we're not on the same page. See how it says if the limit doesn't exist, put in DNE. Let's see. Let's just double check and see if that's the case here. Oh no, that's it. It's 0.6 as well. Hey, let's look at your particular one together. Maybe we can. I don't want to spend too much time on this, and my general thought is at the beginning, if we're a little more organized, we can spend about 10 minutes on this. But we weren't very organized this morning, and that's partially my fault. So if you wouldn't mind, I'd like to move on. And if you want to talk about this one, maybe right after, we could look at your specific question together.
Okay.
All right, are there other questions before we keep going? I want to make sure that we cover enough to make sure that people feel comfortable looking at the homework. As part of my concern here is I want to make sure that this page and the next page are covered before, hopefully by the end of this period. Okay.
Can you hear me?
I can hear you.
Oh, okay. I have a question on number 3.
Sure. You can look at that one very briefly. Go ahead. What's your question?
On the last 3 ones, I tried that one like 40 something times. Yeah.
So telling me you tried it 40 something times makes me feel really bad about it, but it doesn't really help you with the question. So what were you thinking about on this one?
I know that it had to have A in it. And well, it had to have maybe an exponent at the top or something like that. But
so you can see on this particular problem, they're all one-sided limits. And does it say that in the problem? It doesn't say it in the problem, but if you look at the actual limits themselves, most of them are from the left or from the right. And so this is actually, you can see exactly, it's very similar to what's being done on this page right here. So I think it would be helpful if we looked at this page in the notes before we looked at that homework problem.
okay.
Let's look at this. Let's look at the homework, or let's look at the notes, and then we'll come back to that specific question.
Okay.
All right. So we've looked at all these different techniques. The one we haven't looked at yet is the one on this page, this 1 over x to the n, and I had mentioned we'd look at that today. And so this has to do with infinite limits, and that's exactly what the first thing on the page is, right? So it's an infinite limit because the limit is x going to infinity. And so before we kind of evaluate this problem, we should notice something kind of important here. So notice this thing. So in all these limit problems, we're trying to plug the number in there eventually, right? And so it's important to note that infinity is not a number. Okay, it's not a number, it's kind of a concept. But it's you can kind of think of it as a really, really big number, right? And so let's think about some number. Let's let A be a number. What do you think happens if we added infinity to A, or subtracted infinity from some number? Like conceptually to you, and I would love to hear an answer from someone. You can just unmute yourself or throw it in the chat if you really need to. Love to hear your voice though. What, if we took a number and added or subtracted infinity from it, what does that equal? Any number.
I don't know. It doesn't exist.
That's definitely true. It doesn't exist, but kind of conceptually, like, is it a big number or a small number if you added infinity to it?
Wouldn't it be infinity too?
It's still infinity, right? Like if you took 9 and you added infinity, it's still like infinity because you're adding some giant number to 9. In other words, this just like adding a number to infinity doesn't change the fact that it's still just infinity. And the same thing's true if we took a number and we multiplied it by infinity, right? That's still just infinity. And so plugging in infinity, quote unquote, technically it's undefined. Like I'm not sure exactly who said that, but technically it is undefined. But conceptually, adding or subtracting a number from infinity or multiplying a number by infinity just stays infinity. But what happens if we took that number and we divided by infinity? Thoughts about what that might be?
Like infinitely close to 0.
Nice, infinitely close to 0, right? The bigger the bottom of a fraction gets, the closer it gets to 0. So we can kind of think of a divided by infinity as being 0, or like Rory said, infinitely close to 0, right? And so when we have infinite limits, we want to think about this situation, and we want to basically force that situation to exist in our problem. In this current problem, right, in this current situation, so I'm going to write currently, if we plugged infinity into this function, and again, I'm being kind of a bad mathematician by saying plugging infinity in, it's not a real number, but again, kind of thinking conceptually about it. If we plug infinity into this, we'd have like 3 times infinity, we'd have infinity plus 8, and so that's just infinity over infinity. Oops, that's not an infinity, there we go. And so that's one of the indeterminate forms that we have at the top of the page. We haven't seen this one yet, but I'm just trying to sort of lead you down the road to thinking about how to deal with these. Are you with me that that's kind of the issue here? Okay, we're going to try to cram this one in here. I'm trying to do a little explanation, and we'll fit this one at the bottom here. And so the idea then is if we have an indeterminate form that's caused by an infinity like this, what we want to do is multiply by, we're going to do this thing, right? With the, wherever the thing went, where are those things? We're going to do this thing, right? We're going to multiply by 1 over x to the n, where n is the biggest power in the problem. Okay, so let me write that down. So because we have this indeterminate form, maybe I'll just write it down right here. What we want to do is we want to multiply by 1 over x to the n over 1 over x to the n, where n is the largest power in the problem. Because what's going to happen is it'll put all the x's in denominators, and we'll be able to cancel them out and make them 0 based on what we just said about numbers divided by 0. So in this problem, the biggest power is 1, right? We have a 3x to the 1. We have an x plus 8, so it's an x to the 1 plus 8. So we're going to take our original problem and multiply it by 1 over x divided by 1 over x. And so that's what I'm going to squeeze in the bottom here. I'm going to sort of set it up and then pause and see if there's a question. So our original problem is this. This gives us an indeterminate form. And so I'm going to take that and multiply it by 1 over x to the 1 over 1 over x to the 1. Because 1 is the biggest power in this problem. Right? If there was a square in there, it would be a square. If it was a cube, we'd do 1 over x cubed. We just want to cancel out all the x's is the short of it. And we'll make other things go to 0, and we'll be able to get an answer. So I'm going to pause there before we finish and see if there are questions about what I've said or what I've written down. Thoughts there at all?
You don't plug any numbers in for x?
We're eventually, so I'm still writing down the limit, right? So I wrote down limit as x goes to infinity, and we keep writing that down until we quote unquote plug in infinity. So I haven't plugged in anything yet. Yes, eventually we will plug in quote unquote infinity. Thanks for that question. Other thoughts about that? Okay, so the way this works is this thing in the top goes and multiplies the thing in the top in the numerator, and the 1 over x in the denominator is going to multiply both the things in the denominator, right? It distributes through there. And so it ends up looking like this. Right? Everything gets divided by x. And so it lets us cancel out some of the x's. And then we're going to cancel out the other one when we plug in infinity. So like this one cancels out into the number 1, right? Those two cancel out, and we can move forward, and this is going to let us solve this problem.
Question.
Yes, 1 second. Let me finish writing. Yep.
So, like, say the biggest power on the problem is 3. It's only the x's on the bottom that are raised, the denominators.
So this thing that you're multiplying by that I'm highlighting
Mhm.
needs to equal 1, right? You're just taking the problem and you're multiplying it by the number 1. And so it needs to be the same power on the top and the bottom there. Is that what you mean? Like, in other words, you could not put like a 3 here and a 2 down there, because then that wouldn't equal 1. Is
Yep.
that what your question was?
Yeah, I'll keep going and listening.
Okay, so let me actually let me just say one more thing. Let's say there is a 3 right here. Oops. You see how I just put a 3 in that numerator?
Mhm.
Cube right here. Do you see this 3?
Yes.
Okay. So then if that 3 was there, we need to have the biggest power. And so this would need to be a 3, and this would also need to be a 3.
Okay. Sounds good.
That makes sense? Okay. Other thoughts? Other questions before we keep going? We're not done yet, but questions so far? All right, so I also notice, again, that the notation is kind of important. I try not to like kill people over this and take points off, but I'm writing limit in each one of these steps because we haven't plugged in infinity. I'm ready to plug in infinity, and so I'm going to stop writing limit now, right? So I'm just going to write like this. Again, we're not really plugging in infinity, but we're letting x range to infinity. And based on what we just said above, 8 over infinity is just going to go to 0, right? And so this actually ends up being just 3. Questions? See how that worked? Right, we couldn't plug infinity in at the beginning because we just end up with infinity over infinity. But when we divide by the biggest power everywhere, it cancels them all those infinities out, and then just lets us send other ones to 0, and we end up being able to sort of plug infinity in. I can't stress enough how you're not really plugging infinity in because it's not a number, but you're letting it like x range to infinity is what you're really doing there.
So we only do this when the limit goes to infinity.
Right, only when the limit's going to infinity is when you do something like this. Because of this thing, right? Because numbers divided by infinity equals 0. So that's only going to happen when you let the thing go to infinity. Oops.
So when you don't really have a limit, an actual limit?
Say that again. We don't have an actual limit. Is that what you said?
Yeah, when you have like a number that, well, when you have a line that like, well, kind of just goes to infinity.
So this one's going to 3 though, right? This one's actually converging to something.
I see.
Let's graph this one quick. I should be better about doing that occasionally. Let me go ahead and do that. I think I can just pull this up. Let me go to Wolfram Alpha. And let's graph this one. So this one was 3x divided by, I gotta get some parentheses, x plus 8. Right, so it's like this graph right here. Let's focus on the one at the bottom. Right, we're approaching 3. Let me do a quick screenshot so I can draw on this actually. I hate when that happens. Is it back? So this is the graph. I did it again. Damn it. I'm trying to take a screenshot, sorry. Son of a bee. Come on. There we go. Okay. Of course, my screen's not being shared though. All right. Let me try this one more time. Okay. So this is the graph. We're thinking about it at infinity, right? So we're like thinking about this thing as it goes way out this way, right? Infinity is like over here somewhere. And the idea is there's a horizontal asymptote at 3. I didn't do the best job of drawing that, but see how this red line I'm drawing is approximately at the point 3 in the middle? And so way out on the edge of this graph, as this kind of walks down this graph out towards infinity, it's getting closer and closer to that line, and that line is at the point y equals 3. And so the idea is I forget what your original question was. There is a limit, right? So this line is getting closer and closer and closer to the asymptote way out to the right of this thing. And you can kind of see that that's happening in this graph. Let's get a little jumbled now. But questions about that? About the graph at all before I close it off?
Yeah, are all limits asymptotes?
Infinite limits would be an asymptote.
Okay.
Yeah. And you actually, if you just scroll a couple pages down, we define that more formally. There's a section called limits at infinity, and it says that. But absolutely, yep, you're right. Other thoughts? Okay, we'll look at that again. There's a section, if you keep going in the notes, called limits at infinity. It's right after continuity, I think, right? Right after this. We'll get there next week. Anyway, but yeah, you're right. All right, let's look at this last one. This is one technically we should be able to do already, and my goal usually when I run this class is I break people up into groups and let them try this one together. But I would like to just keep moving and make sure we cover the material that I want to cover today. So we've seen how to do this one already, right? So we're approaching 16 in this limit, and notice that if you try to plug in 16, you're going to get 0 over 0. You should try to plug the number in. Okay, there's a handful of limits in the homework that's just seeing, hey, are they checking to plug the number in first? And so that's the easiest thing you should do, is just see if you can plug the number in. If you can, that's the answer. Okay. So what's the technique here then? If you can't do this, what technique do we talk about using if there's square roots that lead to indeterminate forms?
Conjugate?
The conjugate one, right? This one right here, that was the first one we talked about. Talked about when there's square roots leading to issues, you should do the conjugate thing. And so that's how we approach this one. I like doing 2 of these ones because sometimes people think this is a little bit tricky. So I'm going to rewrite the problem and let's solve it. So we can't plug in 16, but we want to take our problem and multiply by the conjugate, which is this. Right, and I messed that up. This should be a 4 on the bottom. Right, so this is the key part, right? The plus in the middle is what makes it the conjugate. We change the minus to a plus. And when we do this correctly, everything cancels out and we get something nice. But we need to be careful because we need to distribute. Right, so we need to distribute the 4 through, we need to distribute the square root through, and we need to like do some algebra. But if you do a couple of these, you just kind of get the hang of it, and they're really not that bad. Right, so I'm going to write the limit again. I'm writing the limit again because we haven't plugged in the number yet. But what ends up happening is we get square root of x squared. We'll get minus 4 plus 4. So those are going to cancel, and then we'll get minus 16. And it's usually better not to multiply out the part that's not going to cancel, right? So this bottom part here that I'm about to highlight, I'm not multiplying that out because we're not going to get interesting canceling things. And instead, one of those factors is going to end up canceling. That's what we saw in the other example, and that's what's going to also happen in this one. All right, let me just pause here. It's been a couple days since we saw this. Questions about it so far? I figured out how to stop the delay on this thing, by the way, so the iPad should be all set. Thoughts? Seems okay. So remember, the square is going to cancel out the square root. And then we've got plus 4 minus 4, so those go away. And so that was the whole point of multiplying by the conjugate, is it cancels a whole bunch of stuff out. So then we get, right, still writing down the limit. This is important. We get x minus 16 on the top, and that's going to cancel with the x minus 16 on the bottom. Right? That's why I didn't want to multiply the bottom out, because I just know the point of this technique is stuff is going to cancel on the top and the bottom. So then those two things cancel. And we can plug 16 into this part, right? So this is still writing down the limit. That's important. Follow my own advice. Still writing the limit down because I have not plugged it in yet. But now we can. We're prepared to plug 16 in. It's not going to lead to something weird. And so we can do that. So I'm not writing the limit down. I'm plugging the number in. And we get an answer.
So thinking as it like graph wise, what does that answer like kind of show us?
Yeah, that's a good question. Let me switch over to the graph. Maybe while people are writing that down, I will graph it on my computer and then I'll show you what the graph looks like. Are there other questions about what happened there while I am graphing? The algebra or anything like that?
So we just get x by itself to be able to see what the limit is.
Yeah, so the idea is just kind of thinking about the whole flow of it. Originally, we tried to plug in 16, and we want to plug in 16 because that's what the problem's telling us to do, right? It says x approaches 16. We want to plug in 16, but when we originally plug it in, we get 0 over 0. And so we multiply by the conjugate in this way, this here, so that stuff cancels, right? This sort of part is stuff canceling. And then this final form is something that we can plug 16 in. And it's the exact same as the original, right? We didn't change the problem. It looks like a different equation. I know it looks different, but we just multiplied by the number 1 and then just did some algebra. So it's actually the same thing. And now we plug 16 into the new form, right? This one here. And that gives us the final answer.
Okay.
Now I just graphed this. I'll just go ahead and draw the graph. I don't need to share my screen. I'll just put it down right here. It turns out it kind of does this. Is it going to 0? Yeah, it's going down to 0. And at the point 16, there's just a hole in the graph. There's like a hole right here. And so the left-hand limit and the right-hand limit both exist on this one, right? If you're doing the left-hand limit, you're kind of walking down here towards that point. The right-hand limit also walks towards the same point. It's just you can't plug that number into this function because it's a weird function. And so instead, we could look at the graph and figure out that it's at approximately 1/8. Or we just learned how to do like some algebra and find it analytically is the way to describe that. Does that answer your question?
Mhm.
Other thoughts? You know, I went through the homework this morning. I haven't taught this class in 3 or 4 years, so the homework's not super familiar to me. So I went back through the homework that's due on Wednesday. I deleted a couple that I thought were redundant. And I think at this point, you should be able to do them all. Maybe the next page actually would be helpful the next page is actually also helpful. I forgot. But in terms of doing them by hand, all the ones that you'll ever do by hand, we've covered. We've covered those 4 techniques, right? Conjugate, 1 over x to the n, factoring, combining things. It's got to be one of those 4 for the homework. Other thoughts for you? Yeah, go ahead.
I have like a kind of stupid question, but
That's the thing.
so you canceled out the numerator and the denominator. Then you were left off with square root of x plus 4. Why did you divide it by 1? Or why did you divide 1 by square root of x plus 4?
So let me do a quick explanation down here. I can actually, let me try this. I've always been wanted to try this. How do you do this? Nah, let's not do that. Let me just zoom in right here and do it right here. You had something like x over x times x, and one of those cancels, right? You still have one on the bottom, but what are you left with on the top? What would you write on the top? It's not 0, right? It becomes a 1 up here. Like when you have something divided by itself, that just cancels into the number 1, right? And so that's what happens here. When you have something like that and they cancel, it just becomes the number 1. Does that make sense?
Yeah, thank you.
And so that's what's going on in that problem then. Just to zoom out again, right? You have like something divided by itself, and so when they cancel, they turn into the number 1. Other thoughts? Is it helpful when I do, if this was on a board or on the document camera, I'd be pointing at stuff. So I think what I'm trying to do in terms of like pointing is this highlighting thing, like saying like, oh, this thing and this thing cancel, and then it becomes like, does that make sense? When I do that, is it real time enough for that to work?
Yeah.
Okay. Other thoughts or questions before we look at the next page? Because the next page mostly focuses on like what I would describe as graphical versions of some of this stuff. It's called one-sided limits, and we're looking at piecewise functions as well on here. Okay. So piecewise functions, let's read what it says here first. So for one-sided limits, we just consider approaching the value from just one of the directions. And we've seen this before, right? We saw this when we were making tables up here. Let me just sort of remind you where I don't have those notes here because we switched over. But way up here when we were making tables, right? There is a table right here on your page, page 3. There's a table there where we were looking at right hand and left hand limits. And that was doing it with a table, and now we're just kind of switching gears a little bit and looking at graphs and functions, piecewise functions specifically. And I'll just kind of remind you of the notation real quick. When we approach something from the right, that's this notation, right, with the plus. And when we approach something from the left, it's got the negative notation, right? It's like the positive and the negative direction. Okay, let's warm up with some piecewise functions, because the graphs that exist at the bottom of the page here that people often get confused about, these graphs down here, these are just piecewise functions. I remember looking at graphs like that, or the one that who asked that question? I think it was Janetta maybe who asked the question at the beginning about the one-sided limits. That's a piecewise function that looks like this. And so those are often defined by things that look like this up top. So how does this function work? Well, basically it tells us that this function f of x looks like x plus 1 to the left of 0, right, when x is less than 0, and it looks like x squared plus 1 when x's are bigger than 0. And so this part on the right tells us when to plug numbers, which piece to plug numbers into. So on the right here, if we want to look at f of 2, we think, is 2 bigger than or less than 0? It's bigger than 0. And so that means we would use the bottom piece for number 2. Right? But negative 4 is less than 0. And so we would use the top piece. I'm going to write that stuff down, just sort of setting up the idea. Right, so if we plug 2 in, we use the bottom piece, and it becomes that. And so we use the bottom piece. Right, these are called piecewise functions because they're in pieces. We use the bottom piece because 2 is bigger than 0. Right, we plugged it in. We plugged a 2 in, and this function tells us to use the bottom piece for bigger than 0. See how that worked? It's really straightforward, but I know when you first look at things that look like these piecewise function, they look really intimidating. So I just like to just start by just reminding you how they work and what they mean. And so since you're defining the function in two separate pieces, it ends up looking weird like the ones at the bottom of the page here. Because, right, it looks, why is it doing that? Use the pen. Use the pen. It ends up looking like these down here because it's like, oh, on this piece, make it look like this shape. And then when you switch over to another shape or another function, it looks like a different shape. Questions about that? Does that seem okay? So then in the bottom piece, if we plug in -4, we would use the less than 0 part, right? So this would be -4 plus 1, which is -3. And we use the top piece because we plugged in -4, and -4 is less than 0. But you see how the two pieces lined up with each other, right? At -3, you actually got the same value. And so you have the same value, which is okay. This has the same output. You're just plugging it into a different piece. Is that okay? Someone want to say something? I heard something there.
What is that word before bottom piece and top piece?
Used, USED.
What's the thing after bottom piece and top piece?
It's an abbreviation for because, B/C.
Oh, okay. All right.
Sorry about that. Still trying to work on my hand. My handwriting's bad to begin with. I'm switching over to iPad is exacerbating that a little bit. Other thoughts? So I just want to sort of clarify that because we're going to look at limits of this now, of that above function. And if we're plugging numbers in from the right, we would want to use one piece, right? And if we're plugging in numbers from the left, we would want to use a different piece, is how this is working. So I just wanted to sort of talk about the pieces before we looked at that. Also notice that these individual pieces are polynomials, right? And so we learned previously, if you just want to just slide up to that thing right here, if we have a polynomial, you can just plug the limits right into them. That's what we learned on Friday. And so let me remind you of that right here. So note, since each piece is a polynomial, we can plug the limits directly into them. Question? Okay, so on the right-hand limit, the one on the left, right, the approaching 0 from the right, this one right here, we're plugging numbers into the right of 0, in other words, bigger than 0, so we would want to use the bottom piece. So if I do the limit as x approaches 0 from the right, I'm using the bottom piece, and so that's going to be this, right? And if I'm doing the left-hand limit, we're going to use the top piece. What do we notice is going on here? Does the limit exist? We did the left-hand limit. We did the right-hand limit. My question to you is, does the limit as x goes to 0 exist? And if it does, what is it equal?
Yes.
What? Say more.
Yeah. So it's 1
Because?
because both of them are the same.
Nice. Yeah, they both exist and they equal the number 1. Let me see if I can give myself some more room here. Great. So the limit as x approaches 0 in general, not from the right or the left, but just the final answer here of this function equals 1 because, and that's b/c, shorthand abbreviation for because the left-hand limit and the right-hand limit both exist and they equal the same thing, right? Because the limit as x approaches 0 from the right equaled the number 1, which was the same thing as we got as we approached 0 from the left. And I also, we graph this. We can graph this one pretty easily because it's not too challenging of a function, right? It's a straight line before 0, and then it looks like x squared plus 1 past 0, or minus x squared plus 1. So that looks like this, right? If we graph that, it would be coming up here with an open circle, and then down like that. Right, this is the x plus 1 part. This is the minus x squared plus 1 part. Let me redraw the second half. It's more like this. I'm going to do a quick summary of what we just did there in a second. But I want to make sure everyone has caught up and has asked anything that they'd like to say before I do that. Thoughts?
So the limit doesn't actually exist. There's a hole in the graph, but there is a limit.
No. The function doesn't exist there.
Okay.
The limit does.
Okay. Makes sense.
That's an important distinction. Those are the kind of distinction we're trying to get into right now. And you'll see down at the bottom here, we're getting into that kind of distinction. We're going to be looking at like, does the function value exist? Does the limit exist? That's the kind of distinction we're trying to get into. So if that's not clear yet, just know we're getting there. But I'm going to look at this graph a little more careful, right? I'm going to zoom in on it. When I'm walking along the left-hand side of this function, I'm approaching that point, this point right there. And when I'm walking around the right-hand side, I'm approaching the same point. So the limit does exist because the left-hand limit and the right-hand limit are both approaching the same point. But the function doesn't exist at that point because there's a hole there. And that's the same thing we've seen on a lot of these problems, like the one we just looked at right here, for example, right? The function, you can't plug 16 into this function because there's a hole there, but the limit exists there. It's just that there's a hole.
Okay, that makes sense.
Other thoughts? That was a good clarificational thing. And again, we're looking, that's the kind of, those are subtle differences, sort of subtle clarificational things that we're starting to get into on this page. Other thoughts? So let's look at a picture version of this same thing. And I'm gonna do this first one, and I'm gonna ask you to think about the second one. So on the first one, oh, my colors just changed. Give me those other colors back. Oh, that's because it's a different thing. Sorry, I get confused. Got distracted there. So here's a different piecewise function. This is a piecewise function of two lines, right? So it'd be like, looks like it's y equals x, and then the other one is y equals maybe minus x plus 4 or something like that. Anyway, when we plug in function values that we first want to think about doing, you want to go to the filled in circle, right? And so this is a hole right here. And this is also a hole right here. Right, so in the first example, if we want to plug in x equals 1, we go up to the graph and it's right here, not in the hole, because there's nothing in the hole is implying there's nothing there, right? So f of 1 is 1. Is that okay? You're not going to the hole. You're going to the filled in circle. Similarly, f of 0 then is right down here in the corner. It's just 0. What's f of 2? Right? If you want to think about where x equals 2 and you go up, there's a hole there. What do you think we should write?
Would it be 1?
So there's a hole, which means there's actually nothing there. Like if we tried to go up to the graph, we would just go right through that hole. And so you would say it's undefined or does not exist or something like that. Oops, not DEN, DNE. Is that okay? See what I'm saying there? All right, let's look at some limits then. Are those function values okay before we look at limits?
Yeah.
So this one here is asking about the limit as x goes to 1, but in order to answer that question, we need to look at the right and the left-hand limits. So we want to look at 4 and 5, and that'll help us answer 6. Okay. If we're looking at the left-hand limit, which is the first one right here, I'm going to draw where that is on the graph. So we're approaching 1 for one thing. So we're thinking about this one. And if we want to approach 1 from the left, we're walking along this graph, this part of the graph, towards this location. And so the limit as x goes to 1 from the left is 1. Is that okay? Right, that's like doing this way. If we approach 1 from the right, we're going the other direction. But that's up on this piece of the graph. And so if we're walking along that piece, what are we getting closer to?
2.
2. All right, so this is a disjoint piecewise function. One of them's coming up from the bottom, one of them's coming up from the top there, and they end up at different locations when you approach it from the left or the right. So what would we say about the overall limit? What's the limit as x approaches 1?
The limit doesn't exist.
It doesn't exist. Nice. Equal DNE, that's a little bit of a misnomer. I don't know. You could just say it doesn't exist. But the key part is why? Because we need the left-hand limit and the right-hand limit to be equal. And so, holes in the graph, just kind of back to the point, one of the points of this page, holes in the graph mean the function's not defined there. That's independent. That's a different thing than talking about the limit. Right? Like this hole over here, I kind of filled it in, but when we were talking about walking along the right-hand limit here, and we were doing up here towards here, yes, there's a hole there, and so the function's not defined at that point, but if you're doing the limit from the right, it's still approaching that point, is the takeaway. And just in case you've lost sight of that, I don't think I've referenced this yet today. It's way back to like the first thing we learned, which was right here. Right, this limit exists if and only if the right-hand limit and the left-hand limit equal each other. Right, so the final limit equals L only if the two left-hand and the right-hand limits equal each other. Okay, so that's what we're applying here, just in a graphical sense. Thoughts? All right, what are these two? Just take a second and think about it yourself. The last two on this one. So approaching 0 from the right and approaching 2 from the left. Those are the end points of the graph, right? That's approaching the left end point coming from the inside and approaching the right end point coming from the inside. we can't talk about the other direction because the function doesn't exist outside those endpoints, and so it doesn't make sense. But just want to sort of do a comprehension check and see what people think about that. Thoughts about either one? What does the right-hand limit at 0 equal?
0.
0. Good. Right, we're like walking down this graph right here towards 0. Oh, saw the chat pop up. Let me see what that said. 7 equals 2. 8 equals does not exist. So I think 7 equals 2. Okay, so let's keep in mind a little unclear about how. Hey, John, could you maybe just clarify either one of those? I just want to make sure everyone's on the same page. When you're approaching, so just kind of zooming in on this. If we're approaching 0 from the right, I'm going to use my highlighter to show this, right? Let me change it to red. We want to walk towards that point from the right. So that means coming down this thing towards that point. Right? That's why this ends up being a 0, because we're heading down towards 0.
Okay.
And
Yeah,
then, so then maybe clarify the number 8 then. What is 8? So if we want to approach 2 from the left, let's go back to the graph. Right, here's the x value of 2. And so we want to be walking down this graph. What would you say for that one?
So if 7 was 0, is that 2?
So we want to be walking towards the number 2 from the left. And so that puts us up on this piece of the graph coming down towards this value.
Is it the y value that I'm giving?
You want the y value, right? Okay, so maybe that's the confusion. Yeah, that helps me understand. So when you're doing this, right, these are x values, but what comes out is a y value.
Okay.
On all of these, right? This is an x value, this is a y value. This is an x, this is a y. Yeah. Does that help?
Yep.
So then what is the last one then?
1, right?
1, yeah. Right, because you're walking down there towards that point. Thoughts? Clarify that for anyone? Okay. So then would you just take just a couple minutes and see if you can do the next one? So on this one, we're just looking at 1. Right, so you're kind of focusing on the number 1. You're doing the left-hand limit and the right-hand limit, and then based on your answer there, you can figure out the final limit. And I'm just going to kind of start noting things, and then we'll look at it sort of together in just a second. So this graph's actually similar to the example we looked up at top. It's very similar to this one up here, where we have 2 things that kind of meet up at the same spot, but the spot they meet up has a hole. Right, it's very similar to this one here. So thoughts? Maybe I should call on someone. Someone who hasn't said something, say something would be great, or I could call on someone, I guess.
So 1 doesn't exist.
Yeah, so f of 1 does not exist. So this is a D and E situation because there's a hole right there. Absolutely. What about the left or right-hand limits? Let me use this colors.
They do exist.
They do exist. Yeah. So what is the left-hand limit?
1.
equals 1, right? When we're walking down the left-hand limit, we're walking towards that hole. And then the right-hand limit is the same thing because you're walking towards the
1.
very same location. Yeah, thank you. Exactly. 1. And so since they both equal each other, they both exist and they equal each other, that means the final limit itself also equals 1, right? Because the limit as we approach 1 from the left is the same thing as we get when we approach 1 from the right. And in both cases, it's walking towards the same point, the number 1, i.e. both one-sided limits exist and are equal. So it's, it's nice if you got a graph, really nice, easy, quote unquote, way to see the limit, if it exists. Clarify that? Anything about that? All right, just checking where we are in the notes. I think we're in pretty good shape. I do think we have time. Just kind of looking ahead here. I think we'll have time on Wednesday to look at homework, for sure. We will have time. And I'm going to look at that homework that I think Janetta asked at the beginning right now. But I'm just trying to think, like, I'm happy to spend time on homework on Wednesday, but it really is going to require you guys to have some questions, right? I'm not going to sort of wait half the class period for people to look through the homework at that point. Please try to look at it before Wednesday. This is your opportunity just to get some of it out of the way, right? Let me help you with some of it. Let's go back to that question that she asked, though. Are there questions about anything on this page before I switch back to that? Oops, so this is the one that was asked about. Let me take a screenshot and we'll look at it. All right, good. So it's, this is literally exactly what we were doing in a lot of these, right? So this is like approaching 1 from both sides and then doing the limit, right? So you like use A and B to answer C, you use D and E to answer F, and then it tries to get you to do it in general. That's sort of, it's like literally the kind of thing we were just looking at, right? And so let's focus in on number 1, right? So this one's asking about 1. So let's go look at 1. So I'm going to zoom in on the graph here and look at the number 1. Right. So if we approach 1 from the left, that's down on this piece. We'll be walking along this piece towards that point. And if we approach 1 from the right, we're up on the other piece. Oops. Would be walking along on this piece towards that number, right? And so this equals 1 and the other one equals 0. Questions about that? Just let me zoom out and look at the questions again, right? So this is 0, 1. Just to reiterate again, because I lose track of what confuses people sometimes. These are y values. Those two things I wrote there are y values. It's saying when the x values are near 1 on the left, what are the y values near, right? Or when the x values are near 1 on the right, what are the y values? Questions about that first one? So then the same thing happens if we approach, oh wait, no, I forgot to do the second part. So this one is, and how does it want us to enter it? What does it say to enter for does not exist? It's just DNE. I don't have it up in front of me anymore. And if I close this out, I'll lose the screenshot.
Yeah, it's DNE.
Just DNE, okay. So it's a DNE because The right-hand limit does not equal the left-hand limit. Is that okay? And was it, did Janetta ask that one? I wasn't really sure. I can't remember who asked that one. I think you're muted, but I think I saw you mouth the word yes. And so a similar thing is going to happen on the other one, right? If we approach -1 from the right or the left, a very similar thing is going to happen because -1 is over here. And so from the right is going to be up here. From the left is going to be down here. We're also going to get a DNE on this one. It's similar. Let's look at the one in general. Hold on 1 second. Yeah. Does anyone want to take a stab at these ones down here? So this is trying to get you to do it in general. It's saying, let's just let A be some integer between -3 and 3. So it's saying somewhere between right here and right here, right? So we're like looking at the middle part of the graph. Can someone in general say what's going to happen? Like notice how when we approached 1 from the left, let me, maybe I'll do it with a highlighter. And, you know, to be clear, this is the kind of thing that math is ultimately trying to get us to do. It's trying to get us to think about things in general, right? You do some specific things to get a general statement out of it, right? So notice what happened on this one. When you approached 1 from the left, the answer was 1. And when you approached 1 from the right, the answer was 1 less than 1. And a similar thing is going to happen with the other ones, right? When you approach -1 from the left, you're going to get
So I get 4 for that, but I didn't know why before. And it's right for question D.
The numbers are different for each person.
Sorry, did someone say something?
So for question D, I put it 4 and it was right. And it's the same question. I have the same.
Did you say 4?
Yes.
There's no equation. I guess I'm confused what you're talking about. We just have a graph here, right?
Yes. D, question D. That's what I said. D. After C.
So what about D?
So the answer was 4, but I didn't know why is it 4 like before. Yeah.
It should be -2, not 4. How are you getting 4? And who's saying that? Let me pull your specific question up to make sure that we're actually looking at the same thing.
It's because the limits go to a different number for each person. So like I have the limit of x to 2.
Yeah, so right. You probably have a different graph, whoever said that. I'm still not sure who said that. Your graph is probably different. Is that what someone's trying to clarify?
Yeah, Rory's saying that people have different graphs, and I believe Abdurrashid asked a question.
Okay, thank you. Yeah, so Abdurrashid or Rashid, you probably have a different number right here. Like it probably looks like the same graph, but the scales are probably different. Does that make sense? Is that true?
Well, I think the scales are the same, but x is going to a different number. So I have x to 2.
Oh, I see what you're saying. So instead of approaching 1, you have approaching 4. I'm sorry, I was confused about what the question even was. So yeah, this is getting back to what I said at the beginning. If you're not familiar with online homework, it gets generated differently for different people. So it'll be like generally the same thing, but it looks like in this particular one, everyone's approaching a different number. But you can still get an answer. Sorry that was confusing. trying
But
to
I
just
really
clarify.
still don't see how you guys got the answer for that.
For which piece?
Well, for D, E, and F.
So we haven't answered it yet. Yeah, I've been waiting for someone to answer, and it sounded like Rashid was just trying to clarify what he had compared to mine. What I'm trying to point out in this, and what you should sort of be able to realize, regardless of what number yours is specifically going to, and I want to just say that one more time, just so no one's confused again. Everyone's number is going to something different, so it's going to be a little bit different. But you should notice how when you approach, let me write it in the middle here. The general thing you should see is when you approach a number from the left, you get one less than that number. And when you approach a number from the right, you get that number. That's what's going on. That's what happened in the thing I showed you right here. And that's what you should also be able to see, regardless of your specific numbers. And so in general, the limit's not going to exist because they're always going to be different numbers.
So should I just put D and E or something?
For which question?
Well, you said they're always going to be different numbers.
So there's three things that you should be entering, right? One of them is this. One of them is this. And then the third one is going to be D and E because they're not the same number. One is A and one is A minus 1. Those are different things. And so that's why the third one ends up being a D and E. I don't have that. The screenshot looks like didn't quite capture that part for me.
Oh,
I guess right here, actually.
Or something like that.
Sorry, what'd you say?
I already tried to put like what's it called, A with exponent with the negative exponent and A with the positive exponent and then D and E.
Oh, I think I know what you're trying to do. Oh, I think you just fill in for D, just put A minus 1, and for E, just put A. I think that's what you gotta do.
Really?
I think. I don't know. I didn't do it yet, but that's what I think.
So I guess I'm a little bit confused. I literally have the answer on my page right here, pointing at the place where it goes. And so I'm obviously not doing a good job of conveying not only what the answer is, but how you get that answer, which is really the more important thing here.
I think Janetta was looking for a numerical value rather than just submitting A minus 1 and A.
No, I did. I actually did put A, like I was putting A's over and over and over again.
Would it be possible for you to share your screen?
By the way, class is over, so you guys are welcome to go, but I'm gonna stick around and work on these homework problems. If Simon wants to stick around and look at that homework problem, we can do that too.
Oh, A minus 1, let me see. A minus 1.
Oh yeah, and this one, it looks like you have to get them all correct, which is unfortunate.
Oh, that seems like it kind of did work, except for still one of them.
It looks like you have the number 4 entered in one of them. Instead of A minus 1.
I do not know.
Right, D should be A minus 1, not 4, which is what you have currently. Or I guess actually.
Okay, thank you, finally. Oh my gosh, that was getting annoying. I don't know why that's the answer. I really do not get how that's the answer at all.
So do you get how A, B, and C worked, or D, E, and F?
Yeah, you made that, you really explained that well.
So notice what's happening in each one of those cases. I don't know what number you have. I still haven't pulled yours up, but on mine, as you can see, when you approach 1, let me erase this. When you approach 1 from the left, the answer ends up being 1 less than that. And when you approach 1 from the right, that's the answer. Right, so I'm just generalizing. It's like when you approach a number from the left, this is 1 is 1 less than it, right? And when you approach the number from the right, you just got the number that you were approaching. And that's the case no matter what that number is. And so that's literally just the answer, right? When you approach a number from the left on this particular graph, you just end up with 1 less than it. And when you approach a number from the right, you get the same number. That's what this says right here.
Okay. Yeah. Then yeah, that makes a little more sense.
Right, it's just saying if you approach a number from the left, you're gonna get 1 less. If you approach the number from the right, you get that number. And since those things are always different, you get a DNE for the final limit.
Okay. Yeah. Thanks.
Other thoughts about this one? Anyone else who's still around? Let me see who's still here. Just got a couple folks left.
Oh, I just have a question, not with the math, but I just have a question with like class. So we're gonna come to the Zoom instead of the Google Meet now, right?
Yeah, I'm trying to use Zoom.
Okay. Are we gonna get a link, or has this link already been sent and I just didn't see it? Is that
It's this link. So I tried to change it in all the places on Blackboard. So it says this on the syllabus, the weekly
Okay.
schedule. I changed the Google Meet link to a Zoom link.
okay?
Did you just click the email I sent this morning? I forgot to change it in the email, which is probably what screwed people up today. But moving
Okay.
forward, it'll be in the email as well.
And it's also on Blackboard too, right? In all the syllabus and all that.
It's also on Blackboard.
All right, cool. Thank you.
Sure. Other thoughts about this problem? I'm happy to look at Simon's in a second here.
Sorry for not meeting you on Friday. Sorry for missing class.
Oh, that's all right. Just would you mind just replying to the email I sent you?
Yeah.
Thank you.
You're welcome. Okay. Bye.
Bye.
You have office hours today, right?
I have office hours at 3:15. Yeah.
Okay. Thank you. Have a good day.
Take care. So Simon, let's take a quick look at that one if you have a second.